Hello, children. We are now ready with a new lesson on topic motion, and this particular lesson will be basically focused on variety questions on the topics distance, displacement, and speed and velocity, which will be helping you to understand these topics in a better way and rather to solve few new questions in your next assignments in a clear and accurate manner. Before proceeding towards the lesson, let's have a review of topics and formulae which we have covered in previous video lesson on motion topic. The topics were distance, displacement, speed, velocity, average speed, average velocity, uniform, non-uniform motion. The formulae which we have introduced were speed is equal to distance by time, velocity is equal to displacement by time, average speed is equal to total displacement by total time, average velocity is equal to total displacement by total time. Now these formulae and the topics will be helping us to solve the variety questions like the short answer, very short answer pattern questions, and also a new pattern question which fall in the category of reason and assertion based questions. Moreover, we will solve n number of numericals which will give you idea about how to attempt the questions based on these topics. It is a suggestion to the students that they should attend the lesson keeping a copy and pen ready so that with the proceeding of the lesson, they also try to attempt the question for the better understanding. Let's start with the first question. I'm reading the question here. Kindly pay attention. Give the name of physical quantity that corresponds to rate of change of displacement. First part of the question. The next part asks you write its SI unit, and the last part includes is it a scalar or vector quantity. Now before directly going towards the answer, I would like to pay your attention towards this term, rate of change of displacement. Children, you should know about the term rate of change of any physical quantity. Here the quantity is displacement. Rate of change of any physical quantity means change in the quantity by time. Now from here we can take out that rate of change of displacement means change in displacement by time. In a way you can understand it like that, displacement by time. And we know that displacement by time represents velocity. So the first part of your question finds its answer. The answer is the physical quantity which have been asked here is velocity. Now it's SI unit. You all know that SI unit we have last time in the lesson only introduced, meter per second. And finally, not a delay to answer that it is a vector quantity. So all the three parts are answered. Moving to the next question, let's see what's the query. A simple question. Distinguish between scalar and vector quantities. Here they are asking you 2 points. The first point, you can recall the definitions of the quantity and give the difference. The difference is these quantities require only magnitude for their complete description. On the other hand, vector quantities require both magnitude and direction for their complete description. This was known to you by the definition of these two quantities. Next to it, see what is the difference coming on. These quantities are represented by using symbol of the quantity. Whenever you have to represent a scalar quantity, you just have to use the symbol of that physical quantity. For example, we know mass is a scalar quantity. So to represent mass, you use small m, which is the symbol of the quantity. On the other hand, for representing vector quantities, we use the symbol of the quantity and we put an arrow over this symbol. For example, we know force is a vector quantity. To represent force, we use its symbol capital F and we put an arrow over here. So it represents the quantity force. Let's go for the next question. The next question is asking you, can distance and displacement be ever equal? If yes, then under what condition? The answer is written in this manner. First, you have to decide whether it is possible or not possible. Of course, it is possible. So the first part of the answer, definitely you should write yes. Then you have to give under what condition. This is possible only when body moves along a straight line without changing its direction. That is when body is moving along a straight path and it's not taking even any turn. Then it is possible the distance and displacement will be equal to each other. So these were some starting level questions. Now, the next question is, even when a body covers equal distances in equal time intervals, its velocity can be variable. Comment giving an example. Now, this situation, we first have to determine whether it is possible or not possible. Now, we know that velocity is a vector quantity. So, when the body is covering equal distances in equal time intervals, the magnitude of velocity will remain constant. But it is possible that the body may be changing its direction of motion continuously or at different times. And in this case, even if magnitude is remaining constant, as the direction is changing, the velocity will be variable. Here, this kind of situation we can observe in a well-known case, and which is the case of when the body is moving in a circular path. We can see here when body moves on a circular path, it can be covering equal distances in equal time intervals. But uh, at every point of the circular path, the direction goes on changing. Direction of motion goes on changing continuously, and that results finally into the situation that velocity becomes variable. So the answer should start with writing yes, and then you have to explain the situation. Coming to the next question now, the query is, an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. Now, even if a minor any movement the body shows, the distance will be there. But it is possible that even if the body is moving any distance, its displacement can be zero. because displacement is the shortest distance between initial and final point or any 2 points. In that case, if initial and final points becomes the same, that is both are the same points, then obviously the result will be zero displacement. So the answer firstly will be starting with see here the answering. You have to write yes, as just now we have discussed that this will be possible. So first you have to write yes. Then you have to give some example to support your answer. The example is another simple situation. When body completes one round on, say, a square path, any shape path you can choose, but here suppose we have taken square path, its distance traveled will be 4 into the length of sight, whereas displacement will be 0 as the body is coming back to its initial position. So its displacement will be 0. So here this question is answered with the support of a suitable example also. Now in the next slide we'll go through some more interesting questions. Let's see what are these categories. Moving on to the next question, let's see what's the query. Write two differences between uniform and non-uniform motion. First difference, we can refer the definition of the two type of motion, according to which in this type of motion, body covers equal distances in equal time interval. On the other side, the non-uniform motion says the body covers unequal distances in equal time intervals. Now, following the first difference, we can take out the second difference, which is saying that in uniform motion, speed remains constant. Now, how it is possible? Speed formula is speed is equal to distance by time. When the distance is equal along with the equal time intervals, the ratio comes to be a constant value. On the other hand, for the non-uniform motion following the same formula, we will get speed to be variable. So these are the two important differences between speed and, uniform and non-uniform motion. Let's move on to the next question. Which of the following is not a unit of velocity? The units which are there in front of you, have a good look over the units. These are meter per second, centimeter per second, kilometer, r to the power minus 2, kilometer per hour. Now, how do we decide which is not the unit? It will depend on the formula of velocity, which is displacement by time. Now, unit of displacement is the unit of length. It can be meter or kilometer or centimeter. And unit of uh, time will be either second or hour. Now, in that way, we can easily see that the third one is not matching with the formula, and that's why our answer is kilometer r to the power minus 2. Moving on to the next question. Let's see what's the query. The question is asking you, giving a situation in a diagrammatic pattern. And the question is, a particle moves over 3/4 of a circle of radius r. Calculate magnitude of its displacement. Now, say A is the starting point over the circular path, and in this direction marked here, the body covers 3/4 of the circle. That means 3/4 part of the circle the body will be covering. And finally, starting from A, it will be reaching on D. So its initial point is A and the final point is D. So definitely AD stands as the displacement of the body. So we have to calculate this value, and this can be done by considering this right angle triangle ODE A, where OD and OA both are the radius. Equally, they are perpendicular and the base of the triangle. So, applying Pythagoras theorem, you can see that the solution is here in front of you. AD is equal to OD square plus OA square, which is finally resulting into the answer of AD as R root 2. This was the sample question based on displacement. Another interesting question in front of you coming on. An ant climbs up 5 stairs. Repeating once again, an ant climbs up 5 stairs, each of width 20 centimeter and height 20 centimeter. Find the distance covered and displacement of ant. Firstly, let's have a look over the situation in a diagrammatic pattern. So this is the view of the staircase. Total 5 staircases are there. Say ant is on the origin of the first staircase. Say this point is A. According to the question, the height and width of each staircase is 20 centimeter. This has been shown in the diagram also, like here, here and here. So in that way, say ant is starting from A. So it will be covering the first staircase, the second staircase, the third staircase, the fourth staircase, and finally it will be on the fifth staircase. And its terminating point, or you can say final point, is B. In this way, we can here see that width and height of the staircases are same. So in that manner, its initial point movement for this complete journey, its initial point is A and the final point is B. Accordingly, its displacement should be directly A to B, the straight line. And for calculating this displacement, we can imagine this completion of right angle triangle in this manner, that is A, B and C, and with the help of Pythagoras theorem we can find out what is the total displacement of ant. Let's see the explanation how we have solved it. Be watchful on the explanation. The explanation says, let A is starting point of first staircase and B is end point after climbing fifth staircase. That already we have explained. In this way, the AB stands as displacement. And as we have already explained you the completion of right angle triangle, you can see the calculation has been carried out. Now, here this how to calculate AC and BC, which will be helping us to find the value of displacement. AC can be easily seen that it is 5 times of 20 centimeter. 1, 2, 3, 4 and 5. Similarly, BC is 5 times of 20 centimeter. So in that manner, value of AC and BC both comes to be equal to 100 and 100 centimeter. Following the Pythagoras theorem, then we get the complete calculation as square root of 100 square plus 100 square, and the final answer stands 10 root 2 centimeter. This is displacement. Now, on the other hand, suppose you have to calculate distance. Distance will be the complete journey length, which will be including, like you can follow the complete journey length, 20 centimeter upward and 20 centimeter horizontally. In that way, it has covered 20 centimeter vertically 5 times and 20 centimeter horizontally again 5 times. The total distance will be equal to, you can easily now calculate, I guess, as we have given you the clue. Let's see, the calculation ends at what? 100 from here, 100 from here. So the total distance comes to be equal to 200 centimeter. So this was an interesting question again on distance and displacement. Let's see another, a kind of thought-provoking question. A body is thrown vertically upwards and rises to height h. Calculate number 1 total distance and number 2 displacement when it is caught back. Definitely a body has to come back if it has been thrown vertically upward. So distance will be again the length of the complete path as it is going up covering h and again coming down covering h. So the length of the path between initial and final point will be h plus h, and that gives you 2h. Whereas when you are throwing the body vertically upward and finally it is caught back after the journey, definitely initial and final points are same, and so displacement stands to be 0. These were some sample questions based on distance and displacements. I hope now you are ready for any kind of fresh question offered to you. In continuation, let's move to the next question, which asks, what is numerical ratio of average velocity to average speed of an object moving along a straight line path? This is a very simple situation which easily can be dealt. Let's go through how it is done. When body moves along a straight path, we know that total distance and total displacement both will be same. Now applying the formula of average speed, we can follow average speed is equal to total distance by total time. Now just now we have compared that total distance is equal to total displacement. So this total distance has been replaced by total displacement, and we now get the formula in the pattern total displacement by total time, which is actually equal to average velocity. So you can now see from here average speed is found equal to average velocity. In that way, now if you take out average velocity by average speed, it will be definitely coming to be 1 by 1, and that is 1:1. So the answer to the situation is that ratio of average velocity to average speed is equal to 1:1. Moving on to the next situation, or you can say next question, we have a car travels a distance of 360 km in 5 hours. What is its speed in meter per second? This is one of the simplest questions. So in spite of giving directly the solution, some instructions have been shared which you can apply and use for solving the question. And the instruction simply mentions that we know the formula of the speed is equal to distance by time. From this, you can put the value of distance as 360, put the value of time as 5 hours, and the answer will be coming in kilometer per hour, which will be converted into meter per second by using the converting factor, which is 5 by 18, and accordingly your answer comes to be 20 meter per second. Now here I think most of you know this converting factor. Still, in case somebody is not aware, let's go through how it is done. We know 1 kilometer is equal to 1000 meter, 1 hour is equal to 3600 second. So if you want to convert kilometer per hour into meter per second, you can put these values and the answer comes to be 1 kilometer per hour is equal to 5 by 18 meter per second. And this factor we utilize for converting kilometer per hour into the equivalent meter per second values. Let's go to the next question now. The next question is given: a train 100-meter long is to cross a river bridge of length 800 meter. What time will it take to cross the bridge, given that the train moves with a constant velocity of 36 km per hour? Few things which you have to note down when we go to the next slide where the solution has been shared. That length of the train is 100 meter and length of the bridge is 800 meter, whereas the speed, which is constant, is equal to 36 kilometer per hour. Now we have to put these values while solving the question. Let's draw a diagram to represent the situations given in the previous question, where it is mentioned that the train is of 100 meters. Say this AB is representing the train and the bridge is of 800 meters. Say this BC is representing the bridge. So when the train has to completely cross this bridge, it will be entering at point B, say. So on entering the bridge at point B, firstly the front part of the train will be covering this BC length, and then unless until the complete length of the train goes through and passes through this complete bridge, then we cannot say that the train has fully crossed the bridge. So for doing that, the train will be covering 800 meter plus its own length 100 meter, and then the complete bridge will be covered. So in that way we can understand the total distance traveled by the train while crossing the bridge will be equal to 800 meter and 800 meter plus 100 meter, which is equal to 900 meter. Now in the question, you have to recall that the speed of the train was also mentioned, which was equal to 36 kilometer per hour, and we would prefer to convert this kilometer per hour value into meter per second for the uniformity of the units. So after converting this value of the speed, we get the value of the speed of the train equal to 10 meter per second. So putting these values in the formula of the speed, which is equal to speed is equal to distance by time, we get the value of time as time is equal to distance by speed. Distance previously calculated 900 meter, the speed which is 10 meter per second. So accordingly, after calculation, the time taken by the train to cross the bridge fully will be equal to 90 seconds. This was the calculation against the given question. Going to the next question, let's see what's the query. A bus travels a distance of 120 kilometer with a speed of 40 kilometer per hour, and it returns with speed of 30 kilometer per hour. That means during the forward journey the speed was 40 kilometer per hour, and during the return journey the speed was 30 kilometer per hour. You have been asked here to calculate average speed for the whole journey. I mean, these kind of questions, let's plot the situation. Say here, the starting point is A and the final point after the forward journey is B. So according to the question, while going from A to B, the distance covered will be 120 kilometer. Here the explanation has been given simultaneously. Now while going from A to B, the distance is 120 and the speed is 40 kilometer per hour. So using again the speed formula S1, where the S1 is the speed is equal to distance by time. We can calculate the time taken during the forward journey, and this comes to be equal to 3 hours by putting the value of distance as 120, putting the value of speed as 40. Similarly, during the return trip, while coming back from B to A, The distance remains the same, 120, but the speed is 30. So the time taken for this trip can be calculated in the same manner, and the value comes to be equal to 4 hours. Now, the solution has been continued on the next slide. I hope you have already got an idea how to proceed. Let's watch. Now, following the previous slide calculation, we can now write total distance is equal to 2 times of 120 kilometer, and that results into 240 kilometer. For the first half journey, forward journey, the time was 3 hours, and for the return trip, the time was 4 hours. So the total time, which is T1 plus T2, equals to 7 hours. Following the formula of average speed, we get to average speed is equal to total distance by total time. The total distance is 240 and total time is 7 hours, and final calculation gives us the result equal to 34.5 kilometer per hour. This was a way how to calculate when the speeds are given and distance is mentioned, then how do we calculate the average speed? Moving on to the next question. A car travels at 54 km per hour for first 20 seconds. Then 36 km per hour it continues with this speed for next 30 seconds. Finally, it is moving with 18 km per hour for next 10 seconds. Means the total journey is in 3 parts. First part for time 20 seconds, the next part is for 30 seconds, and the last part is continuing for 10 seconds. You have to find out here average speed, a simple one, a simple question. Now easily, of course here distance values are directly not given. So you first have to find out the distance values for the different 3 parts. And for that you can depend on the formula of speed is equal to distance by time. And when you apply this formula, you can then calculate the formula. You can then, using this formula, speed is equal to distance by time, and then you can calculate the distance by using it in this form. That is, distance is equal to speed into time. And that results, for the first part, we know the speed is 15 and the time is 20. So the calculation gives you, actually here we have converted some value, children. You have to focus on that. The speed was given in kilometer per hour, 54 kilometer per hour. So by converting it, we get its value as 15 meter per second. The same value we have used here, and that gives the distance equal to 300 meter. Similarly, for the next part, we can see the speed value is 36 kilometer, and that has been converted into 10 meter per second. The time is 30 seconds. Keep on watching children, how the solution has been given to you. Back on the explanation. For the second part of the journey, the distance calculation you can follow. Multiplied, the speed has been multiplied with the time, and it is speed is 10 and time is 30 seconds. So the answer for the distance is 300 meter. Now coming to the final section of the calculation. Distance, the third part, distance is d3 is equal to speed multiplied with time. The speed has been calculated with this value 18 km per hour, which is finally converted into 5 meter per second. Now this 5 we have put here. The time is 10 seconds, and the answer for this part of the distance comes to be 50 meter. Now total distance, you just have to add the 3 sections, that is 300 plus 300 and 50, which results into 650 meter. Similarly, total time, you can add all the 3 parts time intervals, which is 20, which is 20 plus 30 plus 10 finally results into 60 seconds. Now, no delay to solve the answer for average speed. Dividing total distance, which is 650, by total time, which is 60, we results into average speed equal to 10.83 meter per second. This was the end of this calculation. Now, moving on to the next slide, let's see another interesting question. Students, I'm expecting that you are attempting these questions with the proceeding of the uh, complete lesson so that you also feel comfortable to solve these questions even after the completion of the lesson. Moving on to the next question. It comes on: a farmer moves along the boundary of a square field. Shape of the field is square. Square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of farmer at the end of 2 minutes 20 seconds from initial position? Now here the data which are of use we have to focus, but before that let's focus on the diagrammatic view of the field. Say this is the field labeled as A, B, C, D. Let us consider that the farmer is starting from point A. Now, as mentioned in the question, the farmer is taking 40 seconds to complete one round. Now, given time in the question is 2 minutes 20 seconds. This particular time period can be converted into second. You know better that 2 minutes will be equal to 120 seconds. Adding with 20 seconds, the total time given stands equal to 140 seconds. Now, as in 40 seconds, one round is completed. So, we can easily calculate that in 140 seconds, the number of rounds completed will be obtained like this, dividing 140 by 40, and the number of rounds hence comes equal to 3.5. You can even say 3.5 round. Now, it's a very common idea you all have that in one round, the farmer will be completing the perimeter of the field. That is starting from A, it will be coming back on A. This is the coverage of perimeter. So after 3.5 round, quite clear that after 3 round he will be back on A, and after half more round it will be covering the half of the field, half length of the field, and the half length of the field will be from A to C, and that's why his final position after 3.5 round will be C. So if we have to calculate displacement, we have to simply calculate the length of AC. Now applying Pythagoras theorem over the triangle A, B and C, we can calculate the value of AC, and that has been described in the forthcoming explanation which you can follow. Let's focus on that. Calculation is a simpler one, you can easily follow. AC is equal to square root of AB square plus BC square, as AB and BC both are the sides of the square. So putting their values as 10 each, we get the answer for AC equal to 10 root 2 meter. So this is how we calculated the magnitude of displacement in this given case. Here, these were some sample numerical questions based on the topics of distance, displacement, speed, velocity, average speed, and average velocity. Now, a new pattern question have been introduced 1 or 2 years back, and which falls in the category of assertion and reason type questions. In these type of question, uh, statement of reason is given, and just after that, sorry, first a statement of assertion is given, and then after a statement of reason is given, and along with that four choices are given. The choices are like that. I'm reading the choices, kindly follow. First choice may be both assertion and reason are correct statement, and reason is the correct explanation of assertion. Second possibility, both assertion and reason are correct statements, but reason is not the correct explanation of assertion. The third option stands, assertion is correct, but reason is wrong statement. And the final option is assertion is wrong, but reason is correct. Now, whenever any assertion reason based question is given, you have to read both the statements very carefully, and you have to decide that out of these four options, which option suits best. Let's go through one sample question. The assertion statement is displacement of a body may be zero when distance traveled by it is not zero. Hoping you have read the sentence along with my reading. Moving to the reason statement, the displacement is the longer distance between initial and final positions. Now you have to recall the pre-knowledge, whatever we have shared in the previous video lesson, and even here we have applied it time and again. That first assertion statement says that displacement of a body may be zero, and we agree the displacement we have seen in many cases it comes to be equal to zero, whereas the distance traveled may not be zero. May not be zero means distance traveled cannot be zero whenever there is a motion. Of course, assertion statement is a correct statement. But when you see the reason statement, it is mentioning that displacement is a longer distance, which is not possible. Displacement is always shorter one, or you can say shortest distance between the initial and final positions. So following the given four options which we have already discussed and brought in front of you, you can easily understand that assertion statement is right one and reason statement is wrong one. So our correct option will be C option. Assertion is correct, but reason is false. In the next slide, we'll show you one or two more sample questions. Let's have a look over the next sample question in reason assertion category. Assertion statement is when body completes one round on a circular path, displacement is zero. The reason statement is displacement depends on initial and final points, not on path followed by the body. Now, reviewing the assertion statement once again, when body completes one round on circular path, definitely it will be coming back to its initial point, and in that case, the initial and final points are same, and that's why displacement will be zero. So we agree with the assertion statement, which is true. Now, reason is explaining here the displacement depends on initial and final points only. It doesn't depend on path followed. You follow any path between initial and final points. It will be simply depending that initial and final points are two different points or the same points. If initial and final points are same points and the path is any longer path even, so definitely displacement will be zero. So displacement is actually not depending on path followed. So even the reason statement is a correct statement. So we agree with the option number A, which says that assertion and reason both are correct statement and reason is the correct explanation of assertion. Let's move on to the next sample question. Velocity of an object can be uniform or variable. I hope you all are aware of this fact that velocity definitely either can be uniform or it can be variable. Variable means the changing velocity. Reason: velocity can be changed by changing object's speed but not the direction. Velocity can be changed by changing object's speed. What does it mean? Object's speed will be changing when it will be covering unequal distances in equal interval of time. Obviously, in that case, we say speed is variable and we can say that velocity magnitude is also changing. But the remaining part of this reason statement says that it cannot be changed by the direction. In short, it has been written, but not the direction. But we don't agree with this because velocity can be changed either by changing its magnitude or by changing its direction or by changing both. So, even if direction is changed, velocity can be variable or it can be changed. So we do not agree with reason statement. So our correct choice will be answer C, where assertion is true or correct, but reason is wrong. Here we end with the sample questions which we have shown you the way these are solved. Now for you children, we are offering some practice questions based on the complete lesson and the discussion. I expect you should be able to do these questions and then you will be thorough in these topics which we have discussed. Thank you children.